So this question is Leetcode 241, different ways to add parentheses. So we are given an expression and we have to return all possible values of that expression when evaluated. We can evaluate 2 minus 1 first, this portion first, which will give us 1, and then this portion which will give us minus 1, which returns 0, so which is the first value in our array. Then in the second case we can say we solve 1 minus 1 first, which gives us 0, and the final answer is 2. So that is the second value in our array. So this is what we have to do. Let's see the approach. So let's take this example, 2 times 3 minus 4, and try to evaluate all possible answers for this. So the way we do this is divide the equation or expression where the signs are present, because that is where we add brackets after the sign or before the sign. So we'll first break the equation over this spot or this sign. So it will give us 2 and 3 minus 4 as 2 parts. We further divide this at this point, that is the minus sign, so we get 3 and 4 from these two, and we subtract their result the same way we would do here. We would multiply the results. So the base case would be that whenever we reach a single digit, we return it. So when our expression has no signs present in that and we cannot divide it further, it means we have reached our base case. So remember that. So this will return 3, this will return 4, and we will subtract both of them because we have a minus sign here, which will return minus 1, and from here we will get a 2, and 2 times minus 1 will give us minus 2. Another way we could have broken this equation or expression is here at the minus sign. So we could have said that the left part is 2 times 3 and the right part is 4. Then we can further break it up into 2 and 3, and we of course multiply the results and finally subtract here. We have reached the base case for 2, for 3 and for 4. So now we multiply 2 and 3 and return 6 here, and this will return 4, and 6 minus 4 gives us 2. So that will be our answer. So let's make an array where we will store all the computed results and then iterate over our array. So for I, ch in enumerate the expression, we iterate over our expression, which is a string, not an array, and we want to split whenever we encounter an operation or operator. So if our ch in these three operators, then we want to split our string at this index. So the left expression will be expression up to the ith index, and the right expression would be expression from I plus 1th index. Then we want to calculate computed left for self dot different ways to compute. This expression, the left one, and computed right would be, I'll just copy paste it. Right expression. Now we want to match all possible ways and add it to our computed result. So for E1 in computed left and for E2 in computed right, we want to say computed dot append and self dot calculate our number 1, number 2 and our operator. Then finally we return our computed. But remember, we had a base case which says that if there are no operators, we return the expression as a number. So if not computed, it means there was no operator in the expression. So if not computed, return a list with int of expression. Now all we have to do is define the calculate function. So it will take num1, it will take num2 and it will take the operator, and it will say if operator is of addition, return num1 plus num2. If operator is minus, return num1 minus num2. And if it is none, then it is of course multiply, so return num1 times num2. And that is the entire code. So let's run it. Computed right is not defined. Okay. So it gets accepted. Let's submit it. So as you can see, it passes all the test cases, but we can actually add DP to it to make it even better. So we can define DP here and we can make a check if expression in DP, return DP of expression. It's just a minor improvement if we have any repeating subproblems. And before returning, we can just say and we will have to say self keyword here because it is inside a class. Let's run it to make sure it works. Let's submit it. And as you can see, it works.